Welcome to our podcast on installing EdgeDB. Getting started with EdgeDB. Today, we'll delve into the subcategory of installation and setup, providing you with a step-by-step guide to installing EdgeDB on various operating systems. Introduction. EdgeDB is a powerful database tailored for developers, blending the advantages of traditional relational databases with the flexibility of NoSQL. Installing EdgeDB is a crucial first step for learners venturing into this modern database solution. Key facts. EdgeDB is an open-source database crafted to handle complex data with a focus on developer experience. It can be installed on a range of operating systems, including Windows, Mac OS, and Linux. Commands and important concepts. Setup example. Configuration example. Databases example. Practical examples. Conclusion. Understanding the installation process of EdgeDB is vital for any developer aiming to harness its capabilities. Following the correct installation steps and configurations will lay a solid foundation for learning and effectively using EdgeDB. Setting up your first project. Getting started with EdgeDB. In this episode, we'll guide you through creating and configuring your initial EdgeDB project. Introduction. Before delving into coding with EdgeDB, it's crucial to grasp how to set up your first project effectively. EdgeDB is a next-generation database designed for a more intuitive approach to working with data. This guide will walk you through the essential steps to kickstart your first project in EdgeDB. Key facts. EdgeDB merges the power of SQL with the convenience of object relational mapping, ORM, for a streamlined experience. It employs a unique query language called EdgeQL, crafted for ease of use, enabling succinct writing of complex queries. Projects in EdgeDB can be initiated using the EdgeDB CLI command line interface, offering a straightforward method to manage databases and migrations. Important concepts. 1. The command line interface for creating and managing EdgeDB projects, facilitating project initialization, schema management, and query execution. 2. In EdgeDB, the schema defines the structure of your data model, encompassing types, relationships, and properties that represent your data. 3. Migrations are the process through which schema changes are applied to the underlying database, with EdgeDB's migration system aiding in managing the evolution of your database schema. Practical examples. Conclusion. Setting up your first EdgeDB project entails grasping its command line tools, schema definition, and understanding how migrations function. By following the outlined steps, you can establish a robust foundation for your database-driven applications. Connecting to the database. Getting started with EdgeDB. Today, we'll explore how to establish a connection to your EdgeDB instance using various programming languages. Introduction. Connecting to a database is a pivotal step in application development, enabling seamless interaction with your application's data. In the world of database management, connecting to EdgeDB involves using a client library to establish a connection, configure settings, and leverage the database effectively. EdgeDB, built on top of PostgreSQL, offers a higher-level abstraction focusing on ease of use and flexibility. You can access the EdgeDB database through various programming languages using their respective client libraries. When connecting to EdgeDB, you typically need parameters like host address, port, database name, user credentials, and options for SSL and timeouts. A connection string is crucial, as it contains the necessary information to establish a connection to the database, including host, port, database, user, and password. Client libraries enable programmers to interact with EdgeDB from their preferred programming language, providing methods to open connections, execute queries, and manage transactions. Connection pooling is also supported by EdgeDB, helping manage multiple database connections efficiently, thus enhancing performance and resource utilization. In software development, connecting to a database is a fundamental skill. EdgeDB simplifies this process with its client libraries. Understanding connection details such as connection strings and options is essential for effectively managing database interactions. EdgeDB, a next-generation database management system, aims to streamline data management complexities by combining relational database features with modern programming principles. Key features of EdgeDB include its type-safe query language, EdgeQL, enabling easy and secure execution of complex data interactions. The system boasts a flexible schema that can evolve without extensive refactoring, making it adaptable to changing data requirements. Object Relational Mapping, ORM, principles allow developers to interact with the database using familiar programming paradigms rather than raw SQL. Moreover, EdgeDB supports graph-like data models, offering sophisticated data structuring capabilities. The system prioritizes developer experience through features like automatic migrations, built-in testing capabilities, and comprehensive error handling. EdgeSQL, the primary query language in EdgeDB, is designed to be more expressive and human-readable than SQL, supporting querying and inserting operations seamlessly. In today's episode, we delve into the world of EdgeDB, a powerful tool for managing, updating, and deleting data in a user-friendly way. EdgeDB boasts a clear schema that defines types, relations, constraints, and validations, ensuring data integrity and consistency. Its rich type system supports scalar types, custom types, and relationships between types, enabling developers to create structured data models seamlessly. Database migrations are a breeze with EdgeDB, offering tools to manage schema changes alongside application updates effortlessly. Let's dive into some practical examples. With EdgeSQL, fetching users is as simple as running a query like select user id, name, email. Inserting a new user is a breeze with a query like insert username, John Doe, email, john.doe@example.com. Updating a user's email is just as straightforward. Update user filter. Name, John Doe, set email, john.new@example.com. When it comes to querying related data, EdgeDB shines. For instance, fetching posts by a user is a breeze. Select username, post's title, content. In conclusion, EdgeDB bridges the gap between traditional relational databases and modern application needs. Its developer-friendly approach, robust querying capabilities, and powerful schema management system make it a top choice for simplifying database interactions. Schema and types, where we explore the basics of EdgeDB. Understanding schema and types is key to effective database design and interaction. The schema defines the database structure, including data types, relationships, and constraints. EdgeDB's robust type system enhances data integrity and enables complex queries. A well-defined schema is crucial for data integrity, constraints enforcement, and performance optimization. EdgeDB supports type inheritance, promoting code reuse and hierarchy representation. In practical terms, defining types like author and book showcases EdgeDB's flexibility. An author must have a name and can be linked to multiple books, each with a title and optional publication date. Custom types like address can also be defined for reuse. Understanding schemas and types in EdgeDB is vital for effective data modeling. By leveraging the type system and schema definitions, developers can ensure consistent and efficient data management. Join us next time for our podcast on CRUD operations, where we'll explore the basics of creating, reading, updating, and deleting data with EdgeDB. In this episode, we delve into the world of EdgeDB and explore the essential CRUD operations: create, read, update, and delete. These operations are fundamental for effective data management in databases. CRUD operations in EdgeDB are crucial for manipulating data efficiently. They can be executed using EdgeSQL, a query language similar to SQL but with modern features for enhanced usability. Let's break down these operations. 1. Create. Insert user username, John Doe, password, secure password. 2. Read. Select user username, password filter, username, John Doe. 3. Update. Update user filter. Username, John Doe, set password, new secure password. 4. Delete. Delete user filter. Username, John Doe. Mastering CRUD operations in EdgeDB is essential for developers aiming to build applications that heavily rely on database interactions. Understanding these operations and utilizing EdgeSQL effectively empowers developers to manage their data seamlessly. Moving on to advanced EdgeDB features, let's explore EdgeSQL, the declarative query language designed to work harmoniously with the EdgeDB data model. This language supports rich data types, nested queries, filtering, and aggregation, making it a powerful tool for efficient data retrieval. EdgeSQL syntax is influenced by modern programming languages, ensuring developers can easily grasp its concepts. With structured queries and a rich type system, EdgeDB allows for elegant data retrieval and supports user-defined functions for reusable logic within database interactions. Moreover, EdgeSQL facilitates data manipulation through mutations, enabling the creation, updating, and deletion of records. Understanding schema design and management is key, as EdgeQL is tightly integrated with EdgeDB's schema structure. In conclusion, mastering EdgeQL and its advanced features is essential for developers seeking to optimize data management and querying capabilities within EdgeDB. Using EdgeQL, where we explore the intricacies of this powerful query language. In this episode, we delve into the world of EdgeQL and its significance in mastering EdgeDB. Understanding EdgeQL is crucial for harnessing the full potential of EdgeDB, empowering developers to execute expressive and concise queries. By grasping its fundamental principles and practical applications, users can efficiently interact with databases and manage data effectively. Filtering and sorting data, where we explore advanced EdgeDB features. Specifically, we focus on querying data techniques for filtering and sorting query results within EdgeDB. Filtering and sorting are fundamental operations in database management, enabling users to retrieve specific information and present it in a meaningful order. EdgeDB's unique query language seamlessly combines SQL-like functionality with flexibility and user-friendliness. Key facts: EdgeDB is a cutting-edge database designed to simplify data modeling and querying processes. The EdgeDB query language, EQL, is a robust tool for retrieving and manipulating data. Filtering allows users to retrieve entries that meet specific criteria, while sorting organizes entries based on specified attributes. Important concepts: filtering example, sorting example, practical examples, querying data with select product, migrations using EdgeDB migration create, exposing a REST API endpoint to fetch all users. Building an API with EdgeDB can streamline data management and enhance development processes. Empowering developers with knowledge of EdgeQL, schemas, and best practices enables the creation of robust applications with scalable backend solutions. Moving on to our next segment, we explore a case study on an e-commerce application, showcasing EdgeDB in practice. This real-world use case provides insights into building an e-commerce platform using EdgeDB's unique features. Key facts: EdgeDB combines relational and document-oriented approaches for handling complex data types seamlessly. The EdgeDB query language offers an intuitive alternative to SQL, facilitating quick and efficient query writing. A strong type system ensures data integrity and adherence to defined schemas. EdgeDB schemas define the structure of the database, reflecting the application's data model. Join us as we delve deeper into the world of EdgeDB and its practical applications in real-world scenarios. In this episode, we delve into the practical application of EdgeDB in e-commerce and social media platforms. Let's start by exploring the real-world relationships and hierarchies within the data. In an e-commerce setting, key entities such as products, users, orders, and payments play a vital role. EdgeDB allows for the definition of these entities with properties that mirror their attributes. For instance, a product entity may have properties like name, price, description, and category, while a user entity could include properties such as username, email, password, and address. Relationships between entities are essential for e-commerce applications, and EdgeDB supports various relationship types like one-to-one, one-to-many, and many-to-many. For example, user orders signifies that one user can have multiple orders, with each order belonging to a single user. Similarly, product categories illustrates that a product can be associated with multiple categories. Handling transactions is crucial in e-commerce to maintain data consistency, especially during processes like order placement and payment. For instance, ensuring that an order is only placed if the payment is successfully processed showcases the importance of transactions. Moving on to practical examples, let's see how a product type can be created in EdgeDB with required properties. Additionally, we can explore queries to retrieve a list of products with their associated categories and insert a new product into the database with a specified category. Transitioning to the social media platform scenario, EdgeDB offers a modern approach to data modeling that combines elements of SQL and NoSQL. This allows for the creation of complex data models that accurately represent real-world relationships. Complex queries can be executed with minimal code compared to traditional SQL databases, making EdgeDB a powerful tool for real-time data updates and seamless integration with various applications. In a social media platform schema, entities like users, posts, and comments are defined with properties such as id, username, password, created at, content, and more. Leveraging EdgeQL, we can retrieve posts by specific users efficiently. By utilizing EdgeDB in the development of e-commerce and social media platforms, learners can gain practical experience in modern database management. This hands-on approach combines theoretical knowledge with real-world application development skills, paving the way for a deeper understanding of database technologies. Case Study Social Media Platform, EdgeDB in Practice. Case Study Content Management System, EdgeDB in Practice. In this episode, we will explore how learners can effectively engage with modern database challenges, appreciate the nuances of data relationships, and harness the power of a robust querying language for data manipulation. Today, we delve into the subcategory of real-world use cases, focusing on implementing a robust content management system, CMS, that relies on EdgeDB's capabilities. Let's begin by highlighting some key facts and important concepts. Key facts. 1. Schema definition. 2. Example data relationships. 3. Example queries. 4. Example versioning. Now, let's dive into practical examples to better understand how EdgeDB can be utilized in a content management system. Schema definition example. Example retrieving articles. Example adding an article. Example tracking changes. By exploring these practical examples, we can gain a deeper insight into how EdgeDB can enhance content management systems. Join us as we navigate through the intricacies of data manipulation and system optimization. Thank you for tuning in to our podcast on EdgeDB in Practice. Stay tuned for more insightful discussions on leveraging modern database technologies for real-world applications.